Alright, here's our story problem for quadratics. A football is punted into the air. Its height, h, is in meters. After t seconds is given by the equation h equals negative 4.9 t squared plus 24.5 t plus 1. So, the first thing that we're going to do, part A, is we're going to find after how many seconds will the ball hit the ground? Or sorry, will the ball hit its maximum height? Or reach its maximum height? So, anytime we're looking for a maximum or a minimum, we're looking for the vertex. So, the equation that we were given is in standard form or general form, whichever you want to call it. So the formula for that, to find the vertex, is we have that x is equal to negative b divided by 2a. So in our equation, the b value is the 24.5. So since it's negative b, I'm going to have x equals negative 24.5 over 2 times the a value, which is negative 4.9. Okay, so when I do my math, I get that the x value is 2.5, and since our x represents t in our equation, those are the equivalent variables, you would say that it's 2.5 seconds, which is when the football hit its max height. So part B of this is, actually let me scoot that up a little bit. So part B, I want to know how high it will reach at its maximum height. So how high will it reach? So that's its max height at the 2.5 seconds. So we're going to take our 2.5 and we're going to put it into the equation for t, and we're going to find h. So we're going to do negative 4.9 times 2.5 squared plus 24.5 times 2.5 plus 1. And when we do all that, we put in the calculator, make sure you do order of operations, so you do the powers, then you multiply, and then do your adding. You should get approximately 31.6, and that would be in meters. And that's how high it's going to go at the 2.5 seconds. The last thing that I might ask you guys on a test or something is something to the effect of how long will it take the ball to reach the ground? So there's two things going on with this. Well, kind of. So we're looking for time, so we're looking for a t, or the equivalent of an x value. And we know one piece of information is the 2.5 seconds is this max. And what happens anytime we have the vertex of a graph, and I want to know one of the roots, which is where essentially the ball would hit the ground, because if you imagine a little graph here, it goes up and then it goes down. So right here, when it hits the ground, is a root or a zero, an x-intercept. So that will always occur. Let me back up. So the vertex is always halfway in between the two roots. That's kind of what I was going for. So if we know the vertex is at 2.5 seconds, so we just times that by 2. And we get that the ball is going to hit the ground at 5 seconds. So to make that just a little bit more clear, if we look at this graph, here's the function graphed out. And if you look, here's our vertex up here. Oops. Right here. And that is at our 2.5 seconds. So if I was to draw a line down the center, there's my axis of symmetry. It goes through the vertex. That's at approximately my 2.5. My line's a little bit off, but you get my point. And it was at about 31.6 is where it hit its height. Oh man, I can't get that for some reason. So that vertex, you can see, is halfway in between your first root, which is at 0, 0, and your other root, which is at pretty much 5. According to our calculation, it was exactly 5. So that's going to be your key information for story problems on your tests. Is I'll ask you to find some sort of maximum height or minimum height, and its time, and you'll just need to remember that the vertex is always halfway in between the roots, which will help you find other information, or vice versa. Hope it helps. Good luck.